ZEN Smart Target System ZEN STS is a smart and intelligent target system which is used by the armed forces, paramilitary forces and police forces for the live firing practices by their officers and men at the firing ranges. The system is designed in such a way that the target at which a firer is shooting is digitally replicated right next to him, so that he can immediately see the location of his hit on the target for each and every bullet that he fires. In case the bullet has missed the target, he would still be able to see the location of the missed bullet and that how far off he has been from the target within the detection zone. The system is also intelligent enough to keep a record of total number of bullets fired by the firer and is able to discern crossfire as well. Since the firer immediately knows about the location of the hits and the misses of his shots, he can immediately do necessary corrections in the drill he follows so as to get his shots on the target, and if he was on the target, he can make necessary corrections to bring his shots as close to the bullseye of the target as possible. Thus, he can learn from his mistakes during the process of firing itself, or can still learn later as every activity is recorded for post-firing analysis. As per existing range drill and practices, firers after every firing practice are required to walk down to their respective targets to see how they have done, how many shots have hit the target, and how is the grouping of their fire. This is quite cumbersome, tiresome, and a futile exercise which distracts the mind of the firer, and he learns very little from the practice he has just finished. With STS, this wasteful exercise is totally eliminated, and the firer can concentrate on his training in analyzing his performance, correcting his mistakes, and improving his skills. Distance between the firer end and the target end is generally quite large. Depending on the weapon being used for the firing, the distance can be anything between 100 meters to 500 meters or even more. Since STS eliminates the wasteful exercise, a lot of precious range availability time is saved. STS also does away with the practice of manually recording the result and performance of each and every firer, as it automatically maintains such records. This also saves a lot of time. Thus, with STS, time can now be very gainfully used for training of more number of firers during the limited availability of the firing range. It is all the more important as there are not enough ranges to meet the requirements of the units, and units invariably do not get the ranges for firing for the duration they require for the training. Smart Target System comprises of the subsystems which are deployed both at firer end as well as at the target end. Subsystems deployed at target end are Pop-up Target Unit. It is a target system that allows the target to pop up for the trainee to fire at it, and then it goes down. Time of exposure of the target can be set by the instructor or the firer. The system comprises of pop-up target, DC motor with gearbox, power pack, night illumination lamp, self-healing target sheet, test switch, power on indicator, system health indicator, vermin-proof cables and military-grade connectors, hit and return fire indicator, acoustic IH platform. The platform is in the shape of capital H, which is -feet long and -feet wide and is made of aluminium. 6 acoustic sensors fitted on the H platform. Sensor signal processing and control unit. Subsystems deployed at firer end are Firing Point Equipment FPE, Shot Detection Unit SDU, Master Control Station MCS. It consists of a microcomputer, military-grade connectors and specialized application software that are used for calculating the X and Y coordinator of the hit or the miss of the bullet, converting the same into a visual point and displaying it on the FPE monitor. FPE thus displays and records shot location on the target and miss location within the detection zone, number of shots fired, type of exercise in progress, size of the group of bullets, firer score, rating, and the lane operation status. These features help provide real-time instructional and corrective measures to the firers. FPE also sends the coordinates of the hit or miss to MCS, which is displayed on the 22-inch LCD of MCS and is also recorded for replays and analysis at a later time frame. SDU comprises of acoustic sensor, SDU control unit, military-grade connectors. The function of SDU is to detect and record each shot fired from an assigned lane. It also helps in identifying crossfire. If there is out-of-zone shot at a target, acoustic sensors at the target end frame will still detect the shot. But since the SDU placed next to the firer has not recorded the shot, it will be shown and recorded as crossfire at FPE and MCS. MCS comprises of Central Processing Unit CPU, 22-inch LCD, Uninterrupted Power System UPS. The function of MCS is to monitor and control multiple lanes simultaneously and individually from commander station through wired or wireless communication. MCS can override FPE control. Trainee details can be entered from MCS. Similar or different exercises can be assigned for different lanes from the MCS. After the action review and report, printout can be taken from MCS. Custom exercises can be edited using software tool provided in the MCS. Different reports, such as individual trainee performance for the day or for a particular period, all trainees' consolidated report for the day, etc., can be generated from MCS. ZEN STS is a projectile-based acoustic scoring system. The scoring algorithm depends on the precise measuring of Mach cone time of arrival on 6 pressure transducers at the target end. The use of such a scoring system makes the validation of the firer's efficiency very cost-effective. The firer's bullet traveling at a supersonic speed over 450 meters per second creates a supersonic shock wave as it passes through or by the target. The shock wave activates or triggers each of the 6 acoustical sensors fitted in a pattern on the acoustic IH platform. The time difference between triggering of each of the 6 sensors is measured by the system, which is communicated to the FPE through wired or wireless means. The specialized software of microcomputer of FPE uses these time differences in activation of various sensors to calculate X horizontal and Y vertical coordinates of the point of entry of the projectile at the target or where it goes past the target within the detection zone of the sensors. The coordinates are then suitably marked on the target at the FPE, which indicates to the firer the exact location of his hit or the miss within the detection zone. Since the calculation of the coordinates commence only with the detection of the firing of the shot by the Shot Detection Unit SDU at the firing end, any other projectile such as rain, hail, debris, stones, ricocheting rounds or the crossfire from the neighboring lane, etc. will not be considered as hit. Such shots will be displayed as miss at the firer's screen. If the shot does not arrive within the projectile detection zone, that is, if it is too high or too wide or embeds in the earth or is fired at a target in another lane, the system will display such shots on the firer's screen as a miss. Shows shot location on the target and miss location within the detection zone. Displays the group size and mean point of impact for accurate zeroing of weapons. Indicates the lane operation status and allows the control operator to adjust the target exposure time from 2 to 6 seconds. Target can be operated in static or uphold mode. Records single shot slow fire, single shot rapid fire and fully automatic fire. Allows independent operation of each lane without MCS. Comes in both wired and wireless configuration. Contains night illumination facility at each target. Operates between 0 to 50 degrees centigrade. Detects projectiles having a residual velocity of 450 meters per second or more at the target end, irrespective of the firing distance. STS allows zooming in and zooming out and panning of the target on the screen. Allows operator to designate the firing exercise to be fired, that is, lane 1 and 2 for grouping and zeroing exercises, application and classification, and so on. Stores all training, firing data collected and allows printing of the data anytime. Provides at each target and firing point a lane number recognition LNR unit. System is rugged, lightweight, rust-proof and easy to assemble and operate. The system can be operated with 230 volts AC 50 Hz or with DC battery power. System supports up to 18 lanes and is extendable to any number on requirement. Allows operation of individual lanes without dependence on master control station. Annual range course data fed into the system and is ready for training. Exercises can be edited by the user with the help of exercise editor provided in the software.